Hello guys, this is Manuel Gabriel. For the previous assignment, we had looked at the two fundamentals of artificial intelligence. Now we are looking at the Addison in diploma fundamentals of artificial intelligence. And this one I do it according to my project. For example, in my project, for me, I'm dealing with an AI for sign language translation, text and audio system. And we are looking basically at from the 10 modules. That is introduction to AI, problem solving and the logistics, knowledge representation and reasoning, first order logic, resolution and reasoning, probability and certainty, planning in AI, real-world planning and decision making, plus machine learning. For the case of the first module, introduction to AI in the project, here AI enables systems to interpret human gestures, intelligent behavior, recognizing complex hand motions and mapping them to language. For example, weak AI performs only sign to text audio translation, whereas strong AI understands context and conversational nuances. For the historical link, for example, like AI systems are used for interpreting structured data. Therefore, the system interprets structured gestures. For the case of module 2, which is problem solving and logistics, we are looking at the problems we may have in that AI. For example, recognizing hand gestures in real time, the logistics, detecting hand positions, shapes, and movements efficiently. We have filter background noise in video input. These are the problems we have in problem solving and the logistics. We also have mapping gesture sequences to possible words and data mining connection. Preprocessing video data is similar to mining patterns from large data sets. For the case of module 3, where there is a logistics, search and games, gesture recognition can be framed like game strategies, where we can predict the next gesture. Use search to match current gesture sequence with unknown patterns. For example, minimax analog selecting, which is the most likely word from ambitious gestures. Pattern matching in a gesture data resembles predictive modeling. For the case of module 4, we are looking at knowledge representation and reasoning. For the case of knowledge representation and reasoning, basing on our project, we have to represent gestures as features and shape them motion orientation, map features to texture representations. For example, symbolic AI, which has a logical rules for gestures. And this one can be converted to word mapping. We have the connectionist AI, which are neural networks, which are are neutral networks that learn from many examples. For example, the data mining link. Gesture patterns are extracted from data sets. For the case of module 5, we look at the first order logic, and we may have example logic rules. For example, if hand forms A and moves left, this implies that letter A if hand forms B and moves upward, which implies letter B helps define the deterministic rules from unknown gestures. Rules complement ML by handling rare or ambitious gestures. Module 6, we look at resolution and reasoning. AI must resolve ambiguities. For example, same gesture can mean different words in a context. We use logical inferences to select the correct translation, and this one will help us to analyze gesture sequences to find most probable meanings. For module 7, we are looking at probability and certainty, where there is real-time gesture recognition, which is uncertain due to noise, writing, or hand position. For example, the Bayesian networks or probabilistic models assign likelihoods to each gesture, those ones which are the gestures which resemble each other, and this implies word mapping. These probabilistic models improve prediction accuracy for noise datasets. For module 8, we are looking planning in AI. For example, a planning component that converts gestures into smooth, sequential sentences, goal stack. This process gestures in order to form grammatically correct text. For example, strips analog, where each gesture is an action, and this implies text or audio output, which is the goal. These historical gestures patterns will guide this sequence planning. For example, in your world, you are looking real world planning and decision making, which is module 8, where we have real world challenges. For example, multiple gestures at once. We have rapid movements, sequential decisions, and this makes predict intended word when gestures are incomplete, which optimize translation choice based on context. And the system runs from previous translations to improve accuracy, and this one may affect our AI system. For the case of module 10, we are looking at machine learning. Machine learning, it's where there are core ML models used. For example, the convolutional neural networks for gesture recognition, have long short-term memory for gesture sequences, which implies text supervised learning. We have trained on labeled gesture datasets, have reinforcement learning, which is for the future, of course. And the system, this helps the system improve translation through feedback. Another one, training data mining improves learning efficiency. That's what I had for you guys. Welcome to Young.